Hello everyone, welcome to the Matri Virtual. Hope you are doing good. Today I am going to start with chapter number 5, that is continuing of the chapter number 5. In the yesterday's class, that is last class, we have covered the two topics of chapter number 5. Today I am going to continue with the next topic, that is eliminating the loop inefficiencies. The chapter name is optimizing the program performance. That is how to optimize the program performance, or how to optimize the program so that program performance will be enhanced, so that performance of the program will be enhanced and the program will run in a better way, or in a easiest way, or in a shorter period of time. So the main target is to make the program understandable, user friendly, and executes with the less amount of time of the CPU. That is the main motto, that is the main goal. For that we have to do, or we have to achieve certain goals like eliminating the loop inefficiency, making the things understandable, loop unrolling. So all these topics are covered in this chapter. In tomorrow's class, in yesterday's class, we have covered two topics. Now let's discuss we have covered in the yesterday's class. In the yesterday's class, we have started with first topic, that is capabilities and limitations of optimizing the compiler. First of all, we have also discussed about the this definition, that is optimizing the program performance. That is how to optimize, or how to make the program understandable, or how to increase the performance of the program by enhancing the capabilities, by enhancing the resources of the program. Then the first topic we have covered is capabilities and limitations of optimizing the compilers. For this, we have to make understand that what is compiler. So compiler is a computer program. It is nothing but it is also a computer program that transforms, or that converts, or that transfers source code into the programming language code, that is your machine code. So compiler is a program that transforms the source code, or the high level language that is written in the, or that writes the code in the source code into the programming language, that is your machine level language, that is in binary form. So in simple terms, if I say a compiler converts source code into the object code. Source code that is written in any programming language, any high level language. Object code that is written in the machine level language, that is in zeros and ones. So compiler converts source code into the object code. Then we have studied why we are converting into the object code. The main reason is that to create an executable program. Executable program means that we execute automatically when the program runs. The name compiler is primarily used for programs that translate source code from a high level language to the low level language. Example, assembly or machine level language. These are the examples of low level language, like assembly language, machine language. And the examples of high level languages are C, C++, Java, Oracle, and so on. More generally, compilers are a specific types of translators. So compilers are one of the type of the translator that is used to make the compiler, or that is used to make the source program highly compatible to run with the operating system. This says a compiler is likely to perform many of the following functions. Then we have also covered what are the functions that the compiler performs, or what are the operations that a compiler performs. That is lexical analysis, pre-processing, parsing, as well as the semantic analysis. Means lexical analysis, semantic analysis, all these are a part of the compiler that is used to ensure that program will be converted into the machine code very efficiently and effectively. Then we also studied how to optimize the compiler. Till now we have covered what is compiler. Now how to optimize, by providing the efficient mapping of the program. Mapping means the high level language is fully converted into the low level language. Not that only one line is converted, another is pending. No, proper efficient mapping of the program, of the high level language program into the machine level language program. That requires, or this includes, the register allocation, code selection, eliminating the minor inefficiencies. Then next point is don't improve asymptotic efficiency. That is, the programmer do not use the programming languages or the programmer to select the best overall algorithm. Have difficulty overcoming optimization blockers. That is, have a difficulty or it has a difficulty in overcoming the optimization or optimizing the blockers. Then what are the limitations of optimizing the compilers? That is the next topic, that is limitations of optimizing the compilers. That we have covered. That what are the limitations? The main limitation is that every person have a different opinion, have a different programming style. So this is the main limitation. Compiler convert that program that is written by someone else or this program that is written by someone else. So it includes various programming methods like C, C++. There are different syntaxes like C have a printf, cout has a cout, or C++ has a cout. So there are multiple syntaxes that is used for the coding style, for the programming style. Next point says most analysis is performed within the procedures only. Then we have also studied what is the machine independent optimization. That is how we optimize the machine independent code. That is the code that is dependent on only one machine. For example, if I am using one machine that have a different operating system, different processor like i3 processor and the OS is the Windows 7. So if I am executing that code in Windows 7, that should not be compatible or that would not be compatible with another Windows, that is Windows 8, that contains operating system Windows 8 and the processor is i5, for example. So machine independent optimization is very necessary for writing the programs, for increasing the performance of the programs. Then we have also studied about the compiler generated code action. This is the example of the compiler generated code action. This says most compilers do a great job with array code plus simple loop structures. This is the example of loop structures. Then reduction in the strength. How strength will be reduced? What are the reason for reduction in the strength? They say reduce costly operation with simple one. That how to improve or how to gain the strength or how to increase the strength. That is use the multiple operation, use the costly operation with the simplest one or replace. Then use add, addition instead of the multiply or divide. These are the multiple steps that we follow to recover or to increase the performance of the program. Make use of the register, that is everything that must be read or write from the register, not from the memory. Because memory contains primary memory, secondary memory, registers. So the main target or the main motto is that reading and writing the program from the memory itself. Then limitations, what are the limitations? Why we don't use or why the programmer don't use registers? The main reason is that possibility of aliasing. Means if I am giving the registers different names, so there is a possibility of aliasing. Means the names should be different or names are different of the registers. Compilers not always able to determine whether variable can held in the register or not. So it is difficult for the compiler to understand what variable is stored in the register, what are the syntax, what are the data types. This is the example we have covered. Then this is the optimization example. Then next topic we have covered is how to express the performance or the program performance. What are the methods? What is the metric used? The metric used is CPE, that is cycles per element. This includes various topics like absolute time, clock cycle. So absolute time uses nanoseconds, time scale of computer instructions, clock cycles. The metric that is used for that the convenient way to express the performance is known as the CPE, that is cycles per unit. And how we calculate the timing? This is the length equals to n, and the timing equals to CPE into n plus the overhead. Means first of all uses the element, that is CPE, multiplied by the length and includes all the overheads that gives the timing. That is T equals to CPE into n plus overhead. Then this is the example of optimization. This is the procedure how we follow and what is the output and what is the dry run for this program. So that's all for today's yesterday's session. Now I'm going to start with the today's session, that is chapter number 5 continue. So let's start with chapter number 5, that is optimizing the program performance continue. The next topic is eliminating the loop inefficiencies. As the name advises, eliminate the loop inefficiency that have an inefficiency in the looping. For example, if I'm using C, if I'm using for loop, then how to eliminate the inefficiency if there is any in the loop. So that is the main topic, that is eliminating the loop inefficiencies. This is observe that procedure combine one as shown in figure 5. This is figure 5. This is so much. This is figure 5. This is shown as combine one. This is a function that have a different argument. This is the combine one function. This says function VEC vector length as the test condition of the for loop. Recall that the test condition must be evaluated at every iteration of the loop. That is, every condition, every test condition must be evaluated at the every iteration or on every iteration of the loop. Suppose at one time for loop will execute, the same iteration will follow. Second time loop will execute, the same iteration will follow. Or we are following the same iterations, or we are following the same looping on the iteration part. On the other hand, the length of the vector does not change as the loop proceeds. So these are the main drawbacks of the program number 5, of the topic number 5. So this gives a modified version, that is eliminate the loop inefficiency. That is eliminating the limitations of the figure number 5 or table number 5. That is a modified version, that is known as the combine 2, and that is the figure number 6, which calls vec length at the beginning and assign the result to a local variable length. This is the combine 2, which calls vector length at the beginning and assigns the result to a local variable length. This is the example: void combine 2 vec ptrb data t pointer destination. Curly braces start int n, it long int n I, long int length equals to vec vector length v. As I told you, this is used for calculating the length. Suppose v has a different text, v has a 20 characters, so the output of the 20 is going to the length, that is your length variable. That has a data type int, that is your int length. Then using the pointer, that is pointer dest equals to ident. Then using the for loop, first of all starting with 0, ending with the length that is given by the user. That is, it is winding up or it is ending up till the length. Length has a function. This contains a value that has a v, or that contains a v. Suppose v has a 20 characters, so the I is less than 20. That is from 0 to 90. Then I plus plus, that is iteration, increment at every stage, at every iteration. Take the variable that is data t val. Then use the function, use the another function get, that is get vec element vi ampersand val. Then use the destination part, that is pointer dest equals to, that stores the address of the destination of the val. So this improves the efficiency of the figure number 5, that is your looping, that is the for loop. This is the syntax or the analysis what we have achieved after improving the or after increasing the efficiency of the loop. This is function combine 1, 13 page, abstract 01, integer 12, 12, 12, 12.01, 13. Then combine 2, page 4, method, this is integer, integer 10.09, 11.09, 12.09. As you see, if floating point numbers are decrementing, that is 12 to 10, 12 to 11, 13 to 12, 12 to 8, 12 to 8. This optimization is an instance of general class of optimization known as the code motion. This is how we can increase or how we can eliminate the program performance or program inefficiencies. Now let's see with the help of PPTs. First of all, understanding the loop, the same topic or the same example, that is combine 1 go to vecptrv in pointer dest. So this is the combine 1 that is known as the function name, that has a return type void, that has two arguments, that is vecptrv, that has a, this is the return type or this is the data type, that is vector type, variable name is v, this is the data type, that is int. The variable is pointer variable, that is pointer dest, pointer destination. Curly brace open, start, this is the curly brace. Initializing the I equals to 0, that is storing the 0 value to the I. Then int val, and taking the another variable, that is val value, using the pointer and initialize the pointer by 0, that is pointer text equals to 0. Then uses the if condition, if part, that is if I is greater than equals to vector length v. So if I is greater than vector length, that is the length that is given by the v. This is the variable v and this is the data type of vector ptr. So if the vector length v is greater than equals to I, then go to done. Where is the done? This is the done part at the end. Else using the loop part, means if the I is less than vector length, that is initializing or calling the function, that is uses the definition. But if it is greater than equals to length, that is the value that is given by the user, that is beyond the value that is given by the user, then simply go to the done part, that is go to the end part. Loop get vec element, this is your function name. The function name is getting the vector element or get vector element. There are three arguments, that is v, I, ampersand, val. Then destination, that is pointer destination plus equals to val, that is taking the pointer, increment it and storing the values of value or storing the value of val, that is your val variable, means initializing the pointer variable and incrementing the value, store the value of val into the destination. So in simple terms, destination is the pointer variable that stores the address of the val variable. Then I++, that is incrementing the values of I at every iteration. Then again using the if loop or if condition, that is if I is less than vector length, then go to the loop. So this is the same part, go to loop means this one, this is the same part, this is your first iteration, that is understanding the loop. What is the inefficiency in this loop? Procedure vec length called every iteration, that is this function will be called at every iteration, vec length. At every iteration means first iteration is this one when I equals to 0, when I equals to 1, that is next iteration, when I equals to 2, that is next iteration. Same way iteration will be going on and the looping or the vec length element or the function will execute at every time. Then next one says even though results always the same. So whenever we iterate the function, the results are always the same. That is your next inefficiency or next limitation. Now How to remove this limitation? Move EC length call out of the loop. Removing the EC length out of the loop. This is without any loop. Why? At every iteration, the length function, that is the EC length function, will increment, decrement. So there is a wastage of the resources for iterating the values, for iterating the function. So it is instead used beyond the looping, that is, it is used outside the looping, so that it will not iterate every time, because we require value at only one time. So this is the better condition, or this is the better method to write the vec length, that is vector length function, outside the looping. So this is next you are rectified, that is using the loop inefficiency, that is combined to these are the variables, same variable as we discussed with the help of book. Then in the entire int length equals to vec length v, again using the length variable, storing the length value, that is v as a value, that is storing the length to the length variable, using the destination variable, that is pointer variable, initialized to the 0. Now using the for loop, this is next different part, this is different part. Using for loop, that is I equals to 0, I is less than length, I plus plus, incrementing or opening the curly braces, take one variable, that is var, take one function, that is get VEC element, 3 arguments, same, again same, this is the same as we discussed, storing the val address into the destination variable, that is DEXT is the pointer variable that stores the address of the val variable. So this is only the difference is that vec length does not come in the iteration in the looping, so that vec length function is not executing every time and not wasting the resources of the computer. So instead we are using this function beyond the looping. Now, what is optimization? Move code to vec length out of the inner loop. As I told you, value does not change from one iteration to the next. That is, value at every time does not change automatically. That is code motion. CPE, that is cycles per element, is 20.66. Vec length requires only constant time but significant overhead. These are the advantages or the improvement which we covered in the combined two function. By using the vec length function outside the inner loop, so that they will not or the that function will not iterate and change the condition, change the value. This is our next example. Procedure to convert string into the lowercase. String means a set of characters, lowercase means taking the string that is in upper characters, converted into the lower character, that is in small letter. So first of all, using the function, that is lower function, uses the argument, that is char, is a return type, that it returns the value or it returns the type of the char. It returns only single character. Then curly brace open, int I, using one variable, that is I, using the for loop. For I equals to 0, I is less than strlen s. That is taking the length by in the same way but using the function, that is str, because we are using the string. So for using the function, that is strlen, in bracket there is a s because s is a string. This gives this function, that is only strlen s, gives the length of the string, that is your s. Then I plus plus, curly brace open, or this is not open, it's okay, there is no closing also, using the if function. That is if si, that is, this is the array, at one time it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This depends on the length. Suppose I am taken 10, so there are total 10 functions from 0 to 10, that is 11 functions, not 10 functions, 11 functions, equals to a, that is if this is S0 is greater than equals to A and Si, that is S0 is less than equals to Z. If it is lies between the A and the Z, that is string is lies between the A and the Z, then si minus equals to a minus a. That is storing the value, giving the value by subtracting the values and give the value from a to the z, that is from capital A to the small a, capital B to the small b, capital C to the small c. That is how we are converting, or how we are converting the character string into the lower letters or lower case. I'm repeating again. We have taken a function that is known as lower, that is a return type void. There is one argument taken, that is pointer s, that has a return type character. Curly brace is open. Using one variable, that is I, that is of int type. Using the loop, that is your for loop, starting with 0. Condition is that the loop will execute until the length is over, or the length of the s is over, that is strlen s. Then I++ means incrementing the values. Then uses the if function. If si, that is at the 0th location, if it is 0, and at 0th location it is less than 10, greater than a, and the less than 10 or equals to a, or the equals to z, then si equals to a hyphen a, that is a will be replaced by the small a, capital B is replaced by the capital B, capital C is replaced by the capital C. Then curly brace is closed. This says extracted from 218 last summation for 1998. Now, lowercase conversion performance. This is the performance of the lowercase. First one said time quadruples when double string length. That is, if there is a string that is a good character or the good number of characters. So time is double, energy is double, resources are double for executing the code that have a string. Then next point says quadratic performance. That is, the performance will be affected if there is a string instead of the character. So converting the main string or converting the characters into the lowercase. Then this is the performance that is given by the use of diagrams. This is 0.001. These are the figures. That is the middle of 1, 10, 100, 1000. That is a multiple of tens. There are multiple 256. These are the bytes or the bits. 256, 512, 1024, 2048, 4096, 8192, and so on till last one. So this is the performance that is of lower one. That is how we are going from increasing order, that is from 0.002 till 100 point something, or this is beyond the 100 or increment of 100. Then how to convert loop to the goto form, that is converting the loop, that is your for loop or the if loop, into the goto form. That is direct jumping is used for the goto. So how to convert the looping into the goto form? So taking the one function that is your lower function, that is void lower. Lower is a function that has a return type void. Char is a data type that has a pointer variable, that is pointer s. So curly brace is open, int I equals to 0. That is taking the one variable that have a value that is initialized to 0. There is a for loop. If I is greater than or less than, greater than equals to strlen s. That is, if I is greater than equals to strlen s, then directly go to the done. Means directly go to the last part, that is your done, where the done function will done function definition will come. Then there is a loop. If si equals to a and si is less than z, the same syntax, the same values. I++ means instead of using the for loop, I'm using, or here it is using the goto condition and the if condition, or the if values, or the if part. So instead of using the for loop, this is the for loop, the same task. Instead of using for loop, this is used by using the goto function, by using the if condition. The same procedure, the same syntax, the same procedure, and the same looping, same dry run, everything is same. This says strlen executes every iteration. That is, it will execute at the every iteration. Strlen linear in length of string. That is, it gives the or it counts the number of characters in terms of in length of string, must scan string until finds null zero. This is your null zero. That is, always strings will start with the character, and how computer determines or how loop determines that there is the end of the string, that will execute or that will determine by using the null character, and that is denoted by this one. This is the null character. That means reaches at the end of the string. Then its overall performance is qualitative. That is, it increases the overall performance by using the if condition, by using the for loop. Then how to improve the performance? This is the function, that is strlen function will not execute every time within the loop, because the main thing is that the main target is that to increase the program performance, to increase the program efficiency. So strlen will execute every time, it wastes the resources. So if I am using strlen before the for loop, so my task is also done as well as the resources will save. So how to improve? Same procedure, same function, taking the lower function, that is word lower, using the pointer variable, that is pointer is, that have a data type char, curly braces open, int I. That is taking the variable I as a data type or initialize the variable, then int length, that is calculating the length of the string by using the strlen and storing the output into the len variable that have a data type or that have a integer data type. Then for I equals to 0, I is less than len I plus plus. Means starting with 0, ending with the length, that is the length of the string, that is your s, that is your strlen s. Then if si is greater than equals to a, that is at the 0th location, if it is greater than or equals to a, or it is less than or equals to z, that is in between a to z, then increment or replace the a by the capital A by the small a, capital B by the small b, capital C by the small c, capital D by the small d, and so on till z, that is capital Z is replaced by small z. Then this says, or the explanation says, move code to the strlen outside of loop. Why we are moving the outside the loop? The main thing is that it increases or it improves or it reduces the resources or it improves the performance of the program. Next point says, since result does not change from one iteration to another. Form of code motion. This is the form of the code motion. Next point, next figure shows lowercase conversion performance. Time doubles when double string length. When there is a double string length, the time doubles. So this does not improve the performance. This is linear performance. This is string length. This is lower one, lower two. This is lower one, that is a light gray. Dark gray or the black is denoted by the lower two. So this is what we have covered is lower and the lower two. Now next topic is here how to increase the performance or how to increase the program performance by using the procedure or by using the procedure code. So before that, let's take a quick review of your book. The same examples, lower one example, A to Z, that ranging from A to the Z part. This is the example, explanation of the example. This is lower one, the same example, that is converting from string to the lowercase. This is a faster one. Why? Because strlen is using outside the function. This is the lowercase conversion routines, as I told you, with the help of PPTs. Then this is the function that is for a string length of this 1,48,573. That requires just 1.5 milliseconds, that is over 500,000 times faster than the lower one. That is lower 2 is more faster than the lower one. This is the performance that is shown by using the diagram, as I shown you with the help of PPTs. This is the function. Yeah, this is most important. This is a string length, that is 16,384, 32,768, 65,536. These are the different categories, or these are the different margins. These are the different parts of the boundaries. Lower one, this is using these functions. Lower two, using these functions. This is the comparative performance of the lowercase conversion routines. This is the practice problem that you have to practice. What is the output, what is the minimum value, what is the maximum value. Next topic is your reducing the procedure calls. That is, reducing the procedure calls means every time a procedure will call, how to reduce and how to remove the different criteria, or how to remove the branching, so that there is a minimum procedure calls, or there is a minimum function that is used in a function. That is your reducing the procedure call. This is, as we have seen, procedure calls can incur overhead and also block most form of program optimization. That is, whenever we execute the program, whenever we execute one function, that will block or that will incur more overheads. More overheads means there is a large number of overheads, and that will increase or block most form of program optimization. We can see in the code for combine 2 that back element is called on every iteration to retrieve the next vector element. So the main motto is that, the main target is that to reduce the procedure code so that program will execute in a better way, in a faster way. This is combine 3. This is code. This is another code. This is long int I, int length equals to VEC length, data t, pointer data, get VEC start. That is eliminating the function calls within the loop. Now let's see with the help of PPTs. That is optimization blockers procedure code. So the output or the motto is that it is how to optimize the procedure code and how to use the minimum number of procedure that calls the multiple times so that program efficiency will be enhanced. This says, why couldn't the compiler move vec length or the strlen out of the inner loop? Means what is the reason why the compiler itself don't move the function into the or out of the inner loop? The main is that procedure may have side effects, alters global state each time call. So whenever we call the function, whenever we call the procedure, it may alter the global state or it may alter the outer value. The next limitation is that why compiler move, function may not return same value for the given arguments. At every function, every procedure returns some value. So procedure or the function does not return the same value for the given argument. Suppose I am giving 5 arguments. At every iteration, at every part, it gives different values, different functions, or it gives different value. It does not return the same value. It depends on the other parts of the global state. It depends on the values, it depends on the functions, how it will execute and how it will give the output. Procedure lower could interact with strlen, that is lower function will interact with the strlen. Why? There are two procedures, lower and the strlen. If I am using lower function, that is converting the string into the lower cases, that must be combined with the strlen function. Why? The loop depends on the strlen, that is the length of the string. So the lower function depends on the strlen function, that is calculating the length of the string. Next point says, why doesn't compiler look at code for vec length or strlen? This is why couldn't the compiler move? Then why doesn't the compiler look? Linker may overload with different versions, or linker may have a different versions, or overload the values that have a different versions. Why? The main reason is that unless declare static. If it is dynamic, it will execute at every time, it will go at every time, and it will give the or take the different values. Inter-procedure optimization is not extensively due to the cost. The cost is very high, that's why it is not used extensively or larger format. Warning. Compiler treats procedure call as a black box. Black box means it only checks the internal part but does not check the outside boundary or the external parts. Weak optimization in and around them. That is, optimization is weak inside the looping as well as the around the or outside the looping. This is reduction in the strength. There is another example, combine 3, taking the two variable, one is of vector type, another one is a pointer variable that is of integer type. Same, taking the int I, int length equals to vec length, that is finding the length of the v, storing the length into the length variable, using the pointer variable that is data, using the function that is get vec start v, using the or initializing the pointer variable to 0, using the for loop that is for I equals to 0, I is less than length. Length have a value, that have a value, or that have a length of v. I plus plus, using the pointer variable that is pointer est, uses the data I. First of all, it will take or it will increment the data at 0th location, then 1 location, 2 location, 3 location, till the length of the value or the length of the output or the length of the string. That is your reduction in the step. How to optimize? First of all, avoid the procedure call. That is, avoid the procedure call to retrieve each vector element. How to avoid? Get pointer to start of array before the loop. Means this pointer will be used outside the loop or start of a loop before the loop. Within the loop, just do pointer reference. That is, within the looping, just do the pointer reference. That is, giving the reference or by using the argument, by using the ampersand or giving the pointer reference. Not as clean in terms of data abstraction. That is, it will not hide the details. It will not hide the data element. CPE is 6. That is, cycles per element is, that is per element it will execute at each cycle is 6. Next, procedure calls are expensive. Bound check-in is expensive. So next is your how to eliminate the unneeded memory references. Unneeded means there is no requirement of the memory, and how to overtake the memory references. That is your next topic. But before this, let's take a 5 to 10 minutes break and then come back and start with this topic. So let's take a break of 5 to 10 minutes. Let's start with the next topic, that is eliminating the unneeded memory references. This is your next topic, that is how to eliminate the unneeded memory references. So this is also one of the method to increase or to enhance the program performance by eliminating or by diminishing or by removing the unneeded memory references. That is your next topic or next part of improving the program performance. There is a one function used, that is combine for, used for combining. Vector ptrb, the same argument, one is taken as the vector, one pointer is taken as the int variable. Then int I taking the length, that is the length variable, and storing the vector length into the length variable, that is using the function that is veclength of v, and storing the output into the length variable, using the pointer variable, that is pointer data, that is int pointer data equals to get vc start b, then int sum equals to 0. So first of all, taken the variable length that stores the value or that stores the length of the variable of the string v, then uses the pointer that stores the value or the address of the next variable of the next function, that is get vector start v, then using the next variable, that is sum equals to 0, that is initializing the value of sum to the 0. Then using the for loop, that is I equals to 0, I is less than length, means it will execute the length of the b that the user defined, that is starting with 0, ending with the length I plus plus, sum plus equals to data I, that is using the variable sum, increment the value and storing the value into the data I, that is increment at every iteration. Data I means data 0, data 1, data 2, data 3. Then using the pointer variable, that is pointer destination equals to sum, that is it pointer or the destination pointer stores the address variable or stores the address of the sum variable. This is eliminating the unneeded memory references. Optimization, don't need to store in destination until end. This is not used as a storage buffer until the end of the file. Local variable sum held in the register. This is a sum held in the register, not in the memory. Avoids one memory read, one memory write per cycle. CPE is cycles per element is 2. That is memory references are expensive. That is, it is very expensive to use the memory references. Now, how to detect the unneeded memory references? This is the diagram. This is one combine, that is one function, combine 3, combine 2. This is length or line 18, line 24. This is the assembly language program example, that is using the move from register to the register, from ECX to the EDX, for EAX, then adding the operations, then increment the variable or increment the variable values of the register, that is EDX. Then compare the ESI with the EDX. This is the EDX, this is the ESI. So compare the values of EDX with the ESI, then JL, that is jump or jump less than, then LI, that is jump to the LI. In the same way, uses the next line, that is L24, uses the addition operation. This is add L. These are the registers that is used for ECX. Then increment the value, compare the value of ESI with the EDX, then jump to the line 14. Now let's see what is the performance. Combine 3 function, 5 instruction in 6 clock cycles. That is, it combines 5 instruction in 6 clock cycles. Add L must read and write the memory. Combine 4 combines 4 instructions in 2 clock cycles. So combine 5 instructions, combine 4 combines 4 instructions in 2 clock cycles. Then next topic is optimization blocker, that is memory aliasing. That is how to use the memory aliasing, that is given the different name to the memory. This says aliasing means two different memory references specify single location, that is more than one memory reference, more than one address of the memory specify the single location. Suppose there is a location that have a value 10. Two memory reference or the two addresses are used for that location, for that single location. That is known as the aliasing in computer terms. Example, V equals to 3 to 17. Combine 3. That is V, get VC start. That is, this is the function. This is the start function plus 2. Then get VC start V plus 2. This is your next function. Observations. easy to have happen in C. That is, memory aliasing is very easy to access in the C language since allowed to do address arithmetic. Why? The main motto is that why it is easy, because the arithmetic operations is very easy in C language. Then next part is direct access to the storage structure. That is, it has a direct access of the memory. That is, we can easily write and read from the memory. Get in habit of introducing the local variable. Why I am introducing get in habit? Why? Because local variables are inner to the loop. That is not global variable. That is, if a global variable is used, then the whole part or the whole program will execute or use the same number, same variable, same values. But if we are using the inner variable or the inner loop or the local variable, then that variable is within the limit or within the loop only. It is not beyond the loop. That is accumulating within the loop. As I said, your way of telling compiler not to check for aliasing. Then next part is your code motion. That is how we can execute or how we can compile, or what is the advantage for using the memory references. Compilers are good at this for simple loop or array structures. As I told you, if there is a simple memory reference, there is a simple address for the memory. So compiler uses that memory reference for simple loop or the array compilers. Then next point says, don't go well in presence of procedure calls and memory aliasing. Reduction instances using the shift or the add operations instead of the multiply or compile, multiply or divide. Keep registers or data in register rather than the memory, as I told you in the previous class. Share common sub-expressions. Compilers have limited algebraic reasoning capabilities, so that these expressions can be shared or sub-expressions can be shared for the compiler or for executing the or increasing the program performance. Then important tools means what are the tools available? What are the tools available for increasing the performance? That is your next topic. One of the major tool is that measurement. That is how we can measure or how compiler will measure the efficiency of the program, integrity of the program. First tool is measurement. Measurement is used to accurately compute time taken by the code. Suppose I have written the code. So one is the tool that is available, that is a measurement tool is used to accurately compute the time taken by the code in the programming language. How to compute the code accurately? Uses the modern machine have built-in cycle counters. As I told you, there is a counter function, that is count equals to 0, that counts every time whenever we execute or whenever we write the code. So most modern computers have built-in cycle counters that will count at every iteration of the for loop. Using them to get reliable measurements is tricky. That is, using them to get the reliable measurement or to get the proper result is tricky. Then next point says profile procedure calling frequencies. That is, procedure calling frequencies will be reduced by using the, or it is one of the tools that is used for the measurement part. That is Unix tool GPRO. That is, use the tool that is a Unix tool, that is a GPR, or that is used for measurement of the frequencies. Then observation, generating assembly code. Next tool is observation, means how to generate or how to use or how to get the assembly code, that is in assembly language. Lets you see what optimizations compiler can make. Understand capabilities, limitations of particular compiler. That is your observation. That means the analysis part. How you can analyze the assembly code, how you can analyze the machine code, so that assembly part or the machine level language will execute in a better way. That is your observation. Next, this the code profiling example. Shakespeare most frequent words. This is the and I to. This is your task. Count word frequencies in text document. Produce sorted list of words from most frequent to the least. Steps, convert string to the lowercase. So what is the task? Count the number of word frequency in the means the frequency of the word in the text document. Produce the sorted list of words from most frequent to the least. That's starting with the most frequent and ending with the least one. What are the steps? How we can execute it? First of all, convert the string into the lowercase. That is converting the whole string into the lower part or the small cases. Then apply the hash function. There is a function that is available in C language. That is your hash function. Then apply the hash function. Then read the words, that is read the words and insert into the hash table. Then read the word that is available for calculating the frequencies and convert or insert into the hash table. Then modify the list operations, modify the counter, then sort the results. Then data set. Next part is your data set, that is collected works of Shakespeare. That is what are the tools available or what are the data set, that is what is the data requirement for doing the task. Collected words of Shakespeare. These are the collected words, the, and, I, to, of, 946, 596 total words to 26,596 unique words. And then next part is initial implementation of 9.2 seconds. So this is a code profiling example. This is the example Shakespeare word, that is the count of the word, that is how to count the word, if the frequencies or the count the frequencies of the word in a text document. Then next is again code profiling. These are the argument or augment executable program with timing function, that is compute amount of times in spending each function. Then time computation method, that is how to compute the time, that is your time computation method. Periodically interrupt the program, determine what function is currently executing, increments its timer by an interval. That is first of all compute the amount of time, that is how to what is the time requirement or what is the time required to spend the time or the amount of time for each function. Then time computation method means how to compute the time for the function. Periodically interrupt program, that is in every 10 minutes how or the what program will execute or what is the output or what is the interruption that is available in the program. Then determine what function is currently executing. This is one of the best method for calculating the time. That is, if the one program is executing, next program is also executing, then compare the two programs and calculate the time that is required for executing the programs. Increment its timer by an interval. That is, every time the timer will be incremented, that is increment the timer by the interval. Example 10 minutes. Also maintains counter for each function indicating number of times it's called. So always or also maintain the counter or the counting function for each function or the counter for each function indicating the number of times it's called. Then what is the usage or what is the usage of the code profiling? How will we use? That is using the GCC 02 PG program 0 program. That is O program, not 0. What is the usage of program? That is PROG, executes in normal fashion but also generates gmon.out. What is the use of GPROF program? Generate the profile information based on the gmon.out. This is your profiling result, cumulative self, total. This is the time taken, seconds taken. This is the number of time it calls. These are the name. First of all, sort the words. These are the lowercase. Find the elements, adding the header part. Next part is your call the statistics. That is number of calls and the cumulative time for each function. Performance limiter, that is using the inefficient sorting algorithm. Single call uses 87% of CPU time. These are the requirements or the performance criteria. This is your diagram for the code optimization. This is the function for reset, that is a black, then hash function, then lower function, list function, sort function. These are the CPU second. At initial state, this is this one. When we are using the quick sort, this is this one. Iter sort, that is iteration. Iter last, that is at last. Bit table, better hash, linear lower. The first step is that use more efficient sorting function. Uses the function that is more efficient for using the code optimization. Then library function qsort. This is your further optimization, but before that, let's take any book, what is covered in the book. These are the diagrams. That is the same diagram. Line 498, move the SS, RBP, XMNM. That is read the product from the destination. Multiply the product by data I. That is your C coding that is converted into the assembly code. This is the example in the C language. This is combine 4 using the two functions or using the two arguments, that is vector and the pointer variable. There is a one variable that is int I, taking the length variable same, using the pointer variable that is pointer data that stores the address of the get vec start function. Then uses the data C account equal to I10. This is the variable, uses the for function, then using the pointer that stores the address of the account function. This is your for loop, this is your ACC, birth, data, accumulating the result in the temporary location. This is the syntax how we can use, that is a combine 3, combine 4. These are the analysis part or the comparison part. Combine take, direct data access, accumulate in the temporary location. These are the functions for combine 3 and the combine 4. We have discussed about this. This is the practice problem that we have to practice. This is your practice problem, that is how to multiply, then increment, then compare, then store the result. Now let's see what has left in the book or PPT. Now, further optimization, that is how to further optimize the result. Iter first. Use iterative function to insert the element into the linked list. Means use the iteration function, that is every time it will iterate, every time the function will execute, or every time the loop will execute, causes the code to slow down. So whenever we use the iterative function, whenever we use the iteration at the first level, it will slow down the process, it will slow down the elements of the linked list. Iter last. Iterative function places new entry at the end of the list. That is your last in, first out. Means placing the values at the end of the position. Tend to place most common words at front of list. Then big table, increase the number of hash buckets. That is, big table is used to increase the number of hash buckets. Better hash is used for more sophisticated hash function. Linear lower uses the or move the strlen out of the for loop or out of the loop. Any loop, move the strlen function. These are the optimization technique that is used for increasing the program efficiency. Then what is the profiling observation? What we have covered, how beneficial it is, and what are the limitations for using the memory references or increasing the memory references. Benefits are that one benefit is that it helps to identify the performance bottlenecks. That is, it helps to identify the performance bottleneck means identify the performance, that is how it will execute, how full it will execute, and how it is easy to identify the different performance of the profile. Especially useful when have complex system with many components. So it is very useful when there is a complex system and there are so many components available. Then what are the limitations? What are the limitations? Why should we not use or why we are not able to use the memory references? The first limitation is that it only shows the performance for data test case. That is, it shows the performance for the data test case. Only shows means it never shows the performance for the next data, for the PC, for the test cycle, for the execution cycle. No, it only shows the data or the performance of the data for the data testing. That is the data that is used in the programming language, that is used in the function. Example, linear lower did not show big J since words are shown. Quadratic inefficiency could remain lurking in the code. There is an inefficiency of the quadratic function, that is your main limitation in the coding part. Then timing mechanism fairly skewed. That is, the timing mechanism is skewed, that is time intervals, it depends on the program to program, coding to coding. It does not depend on the person to person, but it depends on the program to program. Any program can run for the 3 seconds, 2 seconds, 1 second, it depends on the program to the program. These are the limitations and these are the benefits of the profiling observation. So that's all for today's session. Thank you very much. Now, if you have any doubt, then please text the doubt and I will answer you. But before that, let's take a quick review what we have covered in the today's class. We have started with chapter number 5, that is continue of chapter number 5. We started with the looping inefficiency or removing the loop inefficiency. So first of all, understand the concept of the looping, that is understand the looping. What is the inefficiency that is available in the looping? That is procedure vector length called every iteration, even though result always the same. These are the limitations or the inefficiency. Then how to move the how to get the or increase the efficiency of the program by removing or by move the vec length function out of the loop. This is the loop. Removing the function or move the function outside of the loop, that is that increases the performance of the computer, that increases the performance of the program. How to optimize? Move the code to the vec length out of the inner loop. This is your next example, that is procedure to convert string to the lowercase. Then lowercase conversion performance, these are the conversion performances that is available for lowercase. These are the benefits or these are the diagrams. Then convert the loop to the goto form, that is how to convert the looping into the goto form or using the goto function, that is goto done, goto loop, looping. This is the syntax, that is strlen is executed every iteration in every length of string. Overall performance is quadratic. Then how to improve the performance? This is the function that is used to improve the performance. That is move the call function or the strlen function beyond the or outside of the looping. This is the diagram. Then next topic we have next topic we have covered how to increase the performance of the program by eliminating the procedure code or by reducing the procedure code, that is by reducing the function or by eliminating the function code. That is, the first question is that why couldn't the compiler move vec length or strlen out of the inner loop? The answer is that procedure may have side effects. Why? The global state data or the global variable is eliminated at every time. That is, it alters the global state each time it is called. Function may not return same value for the given argument. Then next point says, why does not compiler looks at the code for the vec length or the strlen? Then what are the warning? Compiler treats procedure call as a black box, weak optimization in and around them. Then how to reduce or what is the problem in the code? What is the why the strength is reduced? This is the method or this is the example why the strength is reduced. Then how to optimize and how to use or how to increase the performance. The simpler method is that avoid the procedure call to retrieve each vector element. Get the pointer, use the pointer references within the loop. Then we have covered how to eliminate, this is the next topic, how to eliminate unneeded memory references. Till now we have covered about the looping, about the efficiency, about the warning, about the procedure calls. Now, next is how to eliminate the unneeded memory references. Unneeded memory references means there is a code or there is an address that is unneeded, that is not required by any variable. That is how to eliminate the unneeded memory references. This is the diagram or this is the example. What is the optimization method? That is how we can optimize or how we can increase the performance. Don't need to store in the destination until end. Local variables sum held in the register. That is, these are the points that is used for optimizing or for increasing the performance of the computer. That is, local variables sum held in the register. Avoids one memory read, one memory write per cycle. CPE cycles per element. Then detecting the unneeded memory references. These are the diagrams that detect the unneeded memory reference. Then how to optimize the memory aliasing, that is the single location is shared by more than 2 memory references. Machine independent optimization summary. What is the code motion? How to reduce the strength. Then we have discussed about the tools that is used for measurement, that is measurement and observation. This is the example we have discussed. What is the code profiling we have discussed, how to use the code profiling, how to profile the results. These are the diagrams that profile the result, code optimization. Then what are the benefits and limitations for optimizing the things. That's all for today's session. Now, if you have any doubts, then please take the doubts and I will answer. So that's all for today's session. Thank you very much for listening me. In tomorrow's class, I will start with your next topic, that is understanding the modern processor. That is how to understand the modern processor with the help of architecture, with the help of computers. So that's all for today's session. We will meet tomorrow.